Hello, good afternoon, friends. Today we start the first topic of bioorganic chemistry, that is introductions to bioorganic chemistry. So, bioorganic chemistry is combination of two branches, organic chemistry and biochemistry. So, in biochemistry, we study the biological processes by using chemical reactions, and in organic chemistry, there is a organic reactions. So, combination of these two chemistry to form the bioorganic chemistry. So, bioorganic chemistry is the branch of life science which deals with study of biological processes using chemical reactions. So, the biological processes, study of biological processes using chemical reactions are called bioorganic chemistry. Means the life science in which we study the biological processes using the chemical reaction is called as the bioorganic chemistry. So many biochemists are studying the biological processes by using the chemical reactions. So in the research, there are two types of research is going on. One is the uh, new research, we call it as a random research, in which the novel molecules are synthesized by the researchers. And another second type of the research is the known molecules are synthesized, their derivatives, study of drugs and preparations of their derivative is known as the applied research. So random research and applied research are carried out by using the different scientists. Okay, so for examples, in case of applied research, the preparation of aspirin and the derivative of aspirin, preparation of aspirin and the derivative of aspirin, that study is in the biochemists are doing this research. Now, the biological processes that occur in the organisms, it contain a chemical reactions, and the study of that chemical reactions is the basic part of the bioorganic chemistry. Now, the all living processes needs energy. So like a machine, the fuel is used to operate that machine, and the machine get operated, produces heat, energy, and some amount of work is done. But in case of the living organisms, the energy is required to maintain the body temperatures, to do work and their metabolic activities, as well as to produce the new kind of organisms. So this energy is obtained in the form of ATP, or the energy stored in the form of adenosine triphosphate. So ATP is an energy rich molecule and which gives the energy to all living organisms. Then biological combustion yield some amount of heat, but large proportion energy is used to derive a molecular engine. So in the biological combustion, large amount of energy is produced. So that energy is used also to do the mechanical work, to produce the heat, and to derive the molecular engines, means the molecular system is carried out by using this energy. Then the bioorganic chemistry is also used for the study of the processes in vitro and in vivo. Means in vitro means in the cell, and in vitro means outside the cell. The chemical reactions are carried out in vitro or in vivo are studied in the bioorganic chemistry. So bioorganic chemistry is the organic chemical researches, that is structural synthesis and kinetic studies towards the biology, is in the bioorganic chemistry. So in bioorganic chemistry, mainly concerned with study of various types of processes. That processes such as oxidation, reduction, then cyclization, dissociation, transport through the biomembrane. So reactions are these type of reactions are occur in the biosystem, biological processes. Now these reactions are carried out by using the reagent, catalyst, and most of the biological process reactions are carried out by using the enzyme. Enzyme are used in this process as a catalyst. So enzyme, specific type of enzymes are used for a particular type of reactions, particular type of biological processes. For example, for the fermentation process, for the uh, photosynthesis process, a particular type of enzymes, cofactors along with enzymes cofactor are also required for the completion of that process, that reactions. Means the biological activity is enhanced by using a catalyst. That catalyst is a enzyme. Now for that purpose, the molecules are oriented in such a way that the reacting site close to each other, or the arrangement of molecule in such a way that there is a particular proper orientation of the molecule to combine with to combine with enzymes, and there is a formation of enzyme substrate complexes, and then there is a biological reactions take place. The reactions occur between substrate and enzyme. Again, enzyme is regenerated and the new product, new substance is obtained. So in bioorganic chemistry, we study more the applications of enzymes. So let's see first proximity effect in organic chemistry. So what is the proximity effect in organic chemistry? Means the reacting species, reacting part come close to each other, and only then only there is a formation of reactions take place. Only if the reacting part come close to, means come close vicinity, close proximity to each other, then there is a reactions take place. For examples, N benzyl nor pseudoephedrine, there is migration of benzyl group from nitrogen to oxygen in case of the N benzyl nor pseudoephedrine. So let's see here. NCO, PH, NHOH. Then there is ME, H, PH, H. This is N benzoyl nor pseudoephedrine. N benzoyl nor pseudoephedrine. Now we see the next point is the proximity effect in organic chemistry. Okay, in the organic chemistry, the proximity effect means the reacting species must be present close to each other so that there is easy attack of one reacting species to another reacting species. Means they are present close vicinity, means close proximity, and then there is a completion of reactions take place, otherwise there is no reactions. For example, N benzoyl nor pseudoephedrine, in this case there is migration of N to O, benzoyl group is migrated, from N to O, means this lone pair attack on oxygen, there is O minus cyclic intermediate formation take place if the reacting groups are present close proximity to each other. So let's see here, this OCPH Then this O minus takes the proton OH, NH, H, pH, here is Me, here is H. Then this OH bond shifting here, then there is NH minus takes the proton. So there is the benzyl group migrated from nitrogen to oxygen through this cyclic intermediate. So there is OCO, pH, Me, H, pH, it will become NH2 and here is H. So this benzyl group is migrated from nitrogen to oxygen, and this is due to the close proximity of these two reacting groups. So the proximity effect in organic chemistry is nothing but the reacting species must be present close proximity, close vicinity to each other, and then there is reactions like this. If this NH-COPH and OH is present anti to each other, then there is no such type of reactions like this. That means there is no migration of benzyl group from nitrogen to oxygens. That is, there is no migration in N-benzyl nor ephedrine. Here is H, OH, and there is pH. There is H, Me, NH, CO, pH. Now it is also N benzoyl nor ephedrine. Now in this molecule, the OH and this N-benzyl group is present anti to each other, and there is no proximity effect, and therefore there is no migration of benzyl group from nitrogen to oxygen, means there is no reaction. As this OH and N-benzyl group is anti to each other, that means there is no proximity effect, and therefore there is no migration and no reactions. Let's see another proximity approach effect in another molecules. Now proximity effect employed in the determination of the stereochemistry of tropane alkaloids. Let's see here in tropane alkaloids NCH3, C double bond COH and H. Now in this case there is this OH group is present in cytropine at equatorial site, and in case of tropine OH is present at the axial site NCH3. Now this is tropine. Okay. So in tropine and inside tropine. Now if there is a benzyl group present on nitrogen instead of methyl group, that is N-benzyl nor cytropine benzyl. Let's see example NCOPH OH. Now it is flipped. If the chain ring is flipped, then this OH goes to axial COPH. And this OH goes to this side and there is H. Then there is migration of this benzyl from nitrogen to oxygen, as these are close proximity to each other, and then there is formation of NH OCOPH. So this product is obtained because this OH attack on this carbonyl O minus, it become OH, then reversal of negative charge, there is formation of NH. Like this, initially we have seen that mechanism. So such type of product is formed. That means again there is, in presence of H plus condition, there is migration of N-benzyl group on the nitrogen, from nitrogen to oxygen. Now such a reactions does not take place if there is N-benzyl tropine is present. So in case of boat form, this is the boat form and it is a chair form. Now in boat form of the benzyl nor cytropine, benzyl nor cytropine, that is pseudotropine, there is migration of benzyl group from nitrogen to oxygen. But in case of NCOPH, both form of the, now this is both form of the benzyl nor tropine, and again sorry, here is H. This N-benzyl group and OH not present on the same side or in close proximity to each other, and therefore there is no migration, means there is no reaction take place. So we can say that the determine the stereochemistry of propone alkylides by using this proximity in the organic chemistry. Okay, let's see another example, conversion of tosylate to acetate by using the proximity effect. Now it is the third example. Tosylate is converted to acetate. So proximity effect is the enantiomeric effect, that is a neighboring group participation, and there is the reacting species must be present close proximity to each other. For examples, the conversion of tosylate to acetate. Let's see here. Here is H methyl group. Now if there is OTS group and here is OCO, CH3. Now this tosylate is converted to acetate. Tosylate group is converted to acetate. So this lone pair attack on this backside attack and there is loss of OTS. OTS is a good leaving group and therefore there is formation of here is HCH3 OC double bond O. This bond formation takes place and there is positive charge. Or sorry, if this bond is shifted on oxygen, then there is positive charge and there is a CH3. Means the lone pair of oxygen is given, and there is single bond and there is formation of carbocation. Such type of intermediate is formed, cyclic intermediate. Then this loss of proton, there is shifting of this bond here. There is formation of C double bond O, and there is acetate. Tosylate is converted into acetate, double bond CH3, and here is OCOCH3, that is tosyl group is replaced by acetate group OAC. So this type of NGP, neighboring group participation by acetate group take place, that is enantiomer effect is take place here, and there is close proximity of these two groups, therefore there is a removal of tosylate by the acetate group. Now let's see another example of anti-7-nor-bornyl paratoluene sulfonate. The substitution of tosylate group is occur in anti-7-nor-bornyl paratoluene sulfonate 10 raised to 11 times easily when there is a syn 7-nor-bornyl tosylate group is present. So if there is double bond and this OTS group is present here, the NGP effect is occur here, and there is OTS group is anti. Therefore, in anti 7-nor-bornyl paratoluene sulfonate, paratoluene sulfonate, the hydrolysis of these reactions take place 10 raised to 11 times faster than the group present on the same phase, is on the same side of double bond. So there is 10 raised to 4 times this tosyl group undergo hydrolysis, acetylation. And lastly, if there is OTS, no double bond, then there is the acetylation of this tosyl group take place only one time faster than corresponding these other things. So let's see more type of example of proximity effect in the next lecture. Thank you.